Okay, let's get started. So, welcome. Today I'm going to talk about Jamstack with Next.js and Prisma. I'd like to thank NG from Contentful and Contentful for organizing this meetup. 2020 has been a strange and wild year, and with all of these events going online, I'm sure you have a lot on your plate. So I'm glad you all made it today. A little bit about myself. So I work as a developer advocate at Prisma, and my background is mostly as a full stack developer for the last 10 years. And during that time, I've had the chance to work on different parts of the stack, from the front end to the back end. I've done some DevOps and infrastructure. And my last gig, I worked on the Web3 stack with Ethereum. And, in the context of Jamstack, I actually began my career with server-side rendered apps using PHP. And then I moved to JavaScript and single-page applications, which dominated the ecosystem up until a couple of years ago when static site generators and the Jamstack came around, and also, PWAs, progressive web apps. And then Next.js came around, which supported this really interesting hybrid rendering model. And so that will be the focus of today's talk. I'll talk a little bit about how Next.js fits really into the Jamstack and how Prisma helps with all of the data aspects. So before I get started, I'd like to do a poll. And you can join that poll by going to slido.com and entering Jamstack in the event code, or you can just scan the QR code. And basically, I have 3 questions. And the reasons that I'm asking these questions is so that I can better adapt this talk to fit really what your level is at and what you're familiar with. So I'm going to wait for some of the responses to come in. Let's see. Okay, so far nothing. Okay. We're not getting much responses, but that's okay. I think I'll just go ahead and give the talk as it is without assuming too much. Oh, okay, we got some. Great. So Next.js and Contentful and Storyblock. Gatsby with Contentful. All right, let's, Redwood.js, that's fantastic. In case you're not familiar, Redwood.js is a great Jamstack framework that also uses Prisma and was built by Tom Preston Werner, the founder of GitHub. Next.js and Prisma. Okay, so I see we have like a nice selection of different frameworks here. I guess this question becomes a little bit redundant. Some of you have used Next.js before, but still would be interesting. All right. And then finally, okay, so about half of you have not used Next.js before. And then finally, let's look. How many of you have used Prisma before? I will introduce Prisma in the talk, but in case you're not familiar, Prisma is the easiest way to access your database from Node.js, gives you type safety, and it makes you really productive. Okay. I think on that note, we can continue. Now, I haven't actually asked this question, but this is what I will be talking about today, which is incremental static regeneration. So I haven't actually asked it, but if you can leave in the comments, I'd love to hear if you've used incremental static regeneration in Next.js. Yeah, just drop a line. Okay, let's get started. So our agenda for today. In the intro, I'll talk a bit about how Jamstack came about, how it compares to other approaches, and the challenges with it in interactive apps. Then I will In the second part, I will explain how Next.js and Prisma fit into this Jamstack architecture. And then finally, in the third part, I'll give a demo of a Jamstack app built with Next.js and Prisma, and maybe even dive to code if time allows. So, introduction. Jamstack and the client-server spectrum. So, as developers, we're often faced with decisions that will impact our application's overall architecture. And in recent years, the Jamstack architecture has gained popularity in the web development community, and I think we've seen it across the web in many different use cases. And the thing is that Jamstack is not a single technology or a set of standards. Instead, it's an attempt to give a name to widely used architectural practices for building apps that aim to deliver better performance and cheaper scaling. Also security. But at its core, the Jamstack says that a web app can be rendered into static HTML at build time, and then that HTML is served efficiently to clients via CDNs, as Anil went into. And this leads us to two fundamental decisions when building an app. And these are, where are you going to implement rendering logic in the application, and where are you going to store data for the application? Now let's unpack that a little bit. So it's worth understanding that this decision of where to implement rendering logic can be seen as a spectrum ranging from one end being server rendering to the other end being client-side rendering, with some approaches sort of sitting in between. So let's start with sort of the classical approach of server-rendered apps. These are also sometimes known as monolithic apps. And these are ones where the rendering logic is implemented on the server side. So that means that the server renders HTML for every request that comes in, perhaps queries the database to sort of hydrate the templates. And this is sort of the approach that would be used in a WordPress app or Rails apps. Then on the other end of this spectrum, on the sort of client-side rendering end of it, we have single-page applications. And these usually have most of their rendering logic implemented on the client side. So for example, you have an application that is written in JavaScript, and then the web server just sends you pretty much an empty HTML page along with the JavaScript code that is needed for your application to actually execute, and then in turn generate HTML, and then manipulate the DOM and sort of render it there. And these are typically used in interaction-heavy apps where page loads are avoided. Now, with a Jamstack approach, rendering actually happens during the build process. And it's actually very common to enhance that statically generated HTML with client-side code, with client-side JavaScript, if you want some more granular interactivity. Now, when it comes to, so this was basically the spectrum and how sort of Jamstack is in this weird position where most of the rendering happens in the build process. And in many cases, you might augment that with some client-side functionality for some more granular activity, especially when it comes to sort of asynchronous CRUD requests to an API. Now, when it comes to where the data is stored, most apps need some kind of storage mechanism for state and data. And typically that would be a database. However, with the Jamstack, it's also very common to use third-party APIs that offer specific functionality. For example, content management with Contentful, payments with Stripe, and e-commerce with BigCommerce or Commerce Tools, as Anil showed us. And the thing is, whichever approach you take, both to rendering and storing your data, you have to realize that these are probably the two critical decisions that will play an important role in building your app and also dictate a lot of the flow of data in your app and how the app is rendered, which leads us to probably one of the most accepted and known challenges of Jamstack, which is rendering immediate user interactions is quite hard. So this is our problem for today. And if you're building a Jamstack app, you'll quickly realize that rendering these user interactions is not straightforward, especially because Jamstack apps typically require you to rebuild the full app for every state change. So for example, if you were to build a blog that allows readers to comment on posts, every time a reader comments on a post, the comment must be persisted, followed by a full rebuild of the app to render that comment. So from a high level, there's two approaches to how we can implement comments in a blog. The first option is we build an API or use a third-party API to store those comment submissions, and then we trigger a build for every submission, which will regenerate the website with the comment. However, this approach works on a small scale, but the moment that every interaction triggers a build, this can easily get out of hand, especially if the builds start taking too long. The second option that we have is to delegate immediate interactions to the client side, and then avoid rendering comments when statically generating the blog. So for example, taking the approach of using discuss essentially uses this approach where the blog post content is primarily pre-generated, and then once the page loads, comments are then fetched and then rendered on the client side. But this sort of defeats the whole point of pre-rendering, because after every page load, a client-side request is made to discuss, to fetch, and render those comments. So now I'm going to start, I'm going to transition into how Next.js solves this problem. So let's talk about Next.js and Prisma and how that fits into the Jamstack. So Next.js supports both static generation and server-side rendering in a single app. Now, the beauty of this is that Next.js, so in case you're not familiar, Next.js is a React-based framework that supports both of these rendering approaches, and it is well suited for the Jamstack because it allows you to define how each page in your app is rendered. So this is because in Next.js, the main building block is a page, and a page is just a React component that is exported from your pages directory, and by default, every page is associated with a root based on its file name. So for example, if you have in your pages folder, in your source code, you have an about.js file that corresponds to the /about root. Now, Next.js solves the problem of these time-costly full rebuilds that Jamstack apps are prone to. And it does that, as we'll see, with this feature called static regeneration, incremental static regeneration. Now, there's one note here. I know that I've said Next.js supports static generations. However, it should be noted that while pages are statically generated in Next.js, if you choose that, Next.js will actually further optimize performance by using prefetch, which is a technique where links on that are viewable in your viewport, it'll actually fetch the props that are necessary to render those, which means that if you click on some of those links, and we will see this in the demo, it'll become a lot more clear. No request actually has to be made to the CDN because it's already loaded in the browser, and then basically page changes, root changes are instantaneous. Now, talked a lot about Next.js. Let's talk about Prisma. So Prisma is an ORM for Node.js and TypeScript that makes working with databases easy. And what we have here on the left side, we have what a query looks like. This is just JavaScript, plain old JavaScript, and a call made using Prisma to fetch a user and its comments, and its associated posts and associated comments with that each one of those posts. Now, Prisma is actually a database toolkit which consists of these three tools. Prisma Client, which is what we saw in the previous slide, used for querying data and interacting with the database. It's basically an ORM. Then we have Prisma Migrate, which is used for database migrations. And finally, Prisma Studio, which is an intuitive way to sort of visually interact with your database. It's basically a UI for your database that is intuitive and quite easy to use. So what are the core benefits of Prisma? Well, it's first higher productivity. The way that it does that, it's Prisma boosts productivity essentially by letting you query data in natural and familiar ways. And then second, increase confidence with type safety, auto completion, and a robust query API. So how do the two fit in together? Well, Next.js and Prisma are coupled together to form quite a powerful toolset for building dynamic Jamstack apps that are backed by a database. So the three ways that you can use Prisma in a Next.js project to fetch or persist data in a database is first static generation, and that is typically done using the get static props function that is exported by each one of your pages in the app. And the get static props function will get called during build time. This is very sort of clear. Then we have server-side rendering, and this is sort of the more classical approach that is common in monolithic apps, where the HTML is generated for each request. And that is usually defined in this get server-side props function. What typically happens when you deploy a Next.js app to Vercel is that for each one of these pages that use server-side rendering, it'll actually deploy a Lambda function, and it'll execute that every time a request comes in. And then finally, you can also define API routes from which you can expose a REST or a GraphQL API. And these are also deployed as serverless functions. So a common example is you can use these API routes to handle async form submissions from the client side. Now, the beauty is really that you can create these hybrid Jamstack apps using static generation for most pages and server-side rendering for others. And I should say that statically generated pages can also be augmented then with some client-side, additional client-side functionality. Now, I think the most exciting feature in Next.js right now, which was, I think, added in version 9.5, is that statically generated pages can be configured to be regenerated at runtime as requests come in. So I've prepared this diagram to demonstrate what that means. So incremental static regeneration, that's what we're talking about here. And this is a feature that can be enabled per page. So imagine that we have a post page, and the post page is followed, has its ID as a parameter here, and user one requests the page, and he gets this version, which is stale. So assuming that when user one requests a page, the backend has already been updated, the sort of the state for this post has already been updated. Maybe I've updated the title, and a request comes in, the stale version is served to the user, and in the background, what Next.js does is it actually regenerates that page, so that immediately when someone else requests that page, or even when user one reloads it, it'll already serve the new version of the page. So how do we enable this in a Next.js app? Essentially, we'll look at this when we get to the code, but all you need to do really is you need to set the number of seconds to wait from the moment a request comes for the regeneration to happen in the background. And the beauty of this incremental static regeneration is that it gives you the performance and scalability benefits of static generation by reducing database and backend load, while also allowing dynamic content, which again, immediate interactions, this was our big challenge. So if you're coming from server-side rendering using WordPress, PHP, Ruby on Rails, you can think of incremental static regeneration like server-side caching with something like Varnish. And the main difference with Next.js is that server caching rules, essentially with this incremental static regeneration, are controlled directly in the application code rather than in a completely separate caching component in your infrastructure. So I know we speak a lot about the beauty of performance in the context of Jamstack apps, but I think some of you even might be surprised to hear that one of the most popular websites on the web still uses server-side rendering, and that is Wikipedia. Now, how does Wikipedia do this with their kind of load? Well, they simply use Varnish, and most requests don't actually invoke a server-side process. but rather they're just served directly from Varnish, which is the cache layer. Now we get to the demo. So in this demo, I'm going to show a blog, which basically has two models. It's very simple. It has posts and comments. And what I'm going to do is in this demo is I'm going to navigate through the blog and show how these two different rendering techniques work and how they perform. And also look at how some functionality is augmented with client-side rendering for these comments. Now, doing these live demos is a slippery slope. So let's pray to the demo gods, or at least be as calm as the Dalai Lama if things don't go quite as smoothly. So let's go to the app. So here I have this app, and what we have here, we have a statically generated page that also uses incremental static regeneration. So I have this button here, and what this will do is, maybe I'll open up the developer tools and have them on the side here. Let's clear it. So I'm going to create a post which will send an asynchronous request to an API endpoint. And that was great. Now, once a post is created, we expect this page to reflect it. Now, if I go reload, this will be like that initial request in the diagram, if you remember. So we got the stale version because the page hasn't been re-rendered, regenerated. Now, if I click reload again, you will see that, oh, we have this new post. So now you can see how even if I do more reloads, they're almost instantaneous. Now I can also go ahead and create another post, and we should see the same thing. The first reload will not yield anything, and then the second reload, there we go, we have it. Now, for each one of these posts, I created two separate pages. One uses server-side rendering, and the other uses static. Now, if I go to the static side, server-side rendering, you can see that it actually took quite a while for it to load. Like if I reload it, you can see that it took, where can I see that? Maybe I can make this a bit smaller. So about 444 milliseconds. And, until the DOM content was loaded, it's about 679 milliseconds. So that's quite a lot. Now, if I open the static, you'll see that it's almost instantaneous. And you also see that there's no request happening. So how does this work? Well, there's another optimization that is baked into Next.js, and that is that, as I mentioned, there's this prefetch. So links to static pages will automatically get loaded if they're in the viewport. So all of these posts, because they have this link to a static page, will actually load all of their once the page load is done, it'll actually load all of their props. And this is what you can see here. Each one of these actually is the ID for the posts. And because they're in the viewport, it'll refetch it. So this page uses, as I said, incremental static regeneration. Now let's look at some of the commenting functionality. So the comments also work similar to the main page, where this page is statically regenerated. And I leave a comment, it'll make an asynchronous request to the API, which will then be followed by adding it on the client side to this list here. So this is where it was added. And you can see that again here. Now, if I reload it, I should probably get the stale version, but the great thing is that in the background, it'll actually regenerate it. So if I'm going to do Command R to reload the page, you'll see that it only has the 3 comments. But if I do that again, you'll see, there we go, we have it. So how does this work? Let's go and quickly look at the code. So I'm going to open up the 2 versions. This is the server-side rendered version, again, to remind you. So we had basically these 2 pages were the same. One was server-side rendered and one was statically generated. And the server-side rendered one essentially just fetches the post, which comes in the parameters, which is in the URL, and then just returns those props, and it does that using Prisma. However, the more interesting one is the one that uses static generation with the incremental regeneration. And in this one, what we actually have to do is we have to define this get static paths. And the reason for that is because we're statically generating the page, we have to know in advance all of the potential parameters that will fit in this URL. And that is, after the post comes the ID. And you can see that here we have this parameter, which is part of the routing functionality of Next.js. So here in this get static paths, we actually find all of the possible paths, and we pass that back in the parameters. And then for each one of these values that we pass here, for each one of these posts, it'll actually, at build time, it'll call this once, each time with a different post ID, essentially, and return that. Now, this is where the incremental regeneration is activated. So here we say fallback true. And the reason that we say that is if we create a new post while the app has already been built, it won't be known to this query. So what fallback true says is that if a request comes into an ID that hasn't been built, it'll actually incrementally try to generate that page by calling this get static props function. And here we have this revalidate function, which says that it'll attempt to regenerate the page when a request comes in at most once every second. So that was pretty much it for the demo. Now I'll come back to the slides. So this is what we saw when we saw this happening both for the root page and both for the statically rendered page. So I'm going to wrap up, and a couple of points just to sort of summarize what we've covered. In essence, Jamstack means pre-rendering the HTML. It's great for content-heavy websites, but challenging for interactive apps due to these time-costly builds. This can be addressed either by enhancing the statically generated content with some client-side rendering functionality, or using the solution of incremental static regeneration in Next.js. I should mention that this is currently only supported by Vercel, and it's no surprise. Vercel were the ones who created Next.js, and there is very tight integration between the two. And then finally, Prisma makes database access easy and integrates well with Next.js. And before we sort of wrap this up, I should probably plug in two other frameworks. There's Redwood.js, which is also a framework that was built with Prisma for Jamstack apps. And there's also Blitz.js, which is a framework that was built also with Next.js and Prisma. But the main idea with Blitz.js is to remove a lot of the overhead of having to define this API layer. And what essentially it does is it gives you this abstraction, so you don't need to sort of define all of these API endpoints. So that's it for me. Thank you so much for listening. And if you have any questions, now's the time.